Assalamu alaikum warahmatullahi wabarakatuh. Welcome back to the presentation of signals and systems. We're in chapter 1 and this is module 1. We're talking about signals. For today's lecture, we're talking about the signals transformation, and the next one will be for the operation. This concept of signals transformation and operation is really a central concept of signals and systems. And this signal and this subject repeats again and again throughout the entire course. So this signals transformation would be discussed right here on continuous time, but it would repeat again when we shift to the frequency concepts and when we go to the transformations from through Fourier transformation, Laplace transformation, Z transformations. And this is again existing when we talk about continuous time or discrete time. So understanding this will help the student to ease his way throughout the entire course. And this is very, very essential concept going over here. Signals transformation has two different main points or main way of expressing it. The first one is through the amplitude, and we're talking about the vertical axis, and the second one will be through time, which is talking about horizontal axis. So two different ways of signal transformation. And when we're talking about the time, we may consider in the future talking about the frequency, but we're talking about the horizontal axis. And when we talk the amplitude, we're talking about the vertical axis, which goes clearly on the vertical direction, whatever signal it is, like x of t or whatever it is. So the amplitude modification and transformation would happen on this axis, the red one, and the time changes or transformation would go with the horizontal axis, which is the blue one showing here. Each of these would have shifting, and this is mainly on what we have like addition operation. Here again, so it will be like shifting, which is positive, like addition, and again here will be shifting again, and it will be addition, so addition or subtraction. So please consider this. So addition, subtractions, or subtractions, addition, both So in both ways of transformation, whether it is amplitude or time, we will find the shifting. And the shifting will be associated with the addition or subtraction operation. And again, it is here shifting, and it is again related to the addition or subtraction operation. Compared to the second way, which is scaling, and this is nothing but just a multiplication operation, and again scaling, which is multiplication operation. So if it is shifting, so it is associated with the addition or subtraction. If it is scaling, then it will be associated with multiplication operation. And scaling would be like amplification, attenuation, or compression, expansion through time axis. After we cover this, we will move to the multiple transformation, where we have multiple of these transformation applied to the same signal, and the next lecture we'll talk about signal operation. Let's go a little in depth and see how each of these happening. As an example, to understand physically how this is going to happen, like a pilot who's working on an airplane when he controls the system of the airplane through moving one of these arms, the pilot is doing nothing but just transferring an electrical signals or mechanical system into a different signals that controls the aircraft velocity. So this is a way of transformation. So moving a joysticks uh, forward or backward, or pressing on a paddle like downward or leaving it upward, these type of actions will be transferred as an electrical signals or mechanical signals, and then it will reach to somewhere to change the airplane velocity. So these are some type of transformations happening in our daily life. The common classes in signal transformation are applicable in both continuous time and discrete time. However, the examples covered in this lecture will be concerned only with the continuous time signals. Now, let's start with the first type of this transformation, the amplitude shifting. And as I told you, shifting is associated with addition operation. So we have a signal x of t, which is given over here. If we want to transfer the signal, which is, let's say this is a signal, and we want to transfer it to a prime signal. And what is a prime signal? It's just x of t plus b. This is called normally a DC. So DC component, as you can see here. So adding a constant to a signal, meaning that we are adding to the value of x the value b, which is constant, at each and every value of t. So at each point, whatever value it is there, we will add b. Then at this point we will add b with the same distance b, and again doing it same here, b, and there, b. And what we will reach to another signal which is somehow in similar shape, but it is shifted upward. So this is the new signal that is happening after transformation. So if b was positive, then it will be shifting upward. So we will shift this signal upward and we will get this a prime signal. So this is a prime and this is signal a. And if we are doing it in a negative direction, so b is negative, so we will move this signal downward. This is negative b. We will move it downward and we will have, this is like, let's say this is a prime and this is a double prime. So this is now -2, so this is a double prime signal, which is shown here. Now, the second type of amplitude transformation is what is called amplitude scaling. And whenever we're talking about scaling, we will talk about multiplication. So we are multiplying this constant to the signal. So it is either amplification or attenuation. So what we're doing is that we are multiplying a by x of t at each and every value of t. So if a was positive, if a was greater than 1, the absolute value of a was greater than 1, then we're doing a amplification. And if it is less than 1, then we are doing an attenuation. We will see it next slide. Then if it happened to have a is as a negative, then we will have what's called flipping. So we will flip the signal upside down, as we're going to see, and this will happen around the horizontal axis. So whatever was upside, it will move toward downside, and whatever was downside, it will move upside. It will flip. So here's the three different cases. This is the signal x of t, the original signal x of t. So if we multiply it by a number which its magnitude is greater than 1, then we're doing an amplification. So this was all the way up to 1 and all the way up to -1. So when we multiply it by 2x, then it happened to have all the way up to 2 and all the way up to -2. So this is an amplification transformation. Second is if a absolute value of a was less than 1. So let's say it is half. So previously it was to 1, then when we multiply it by half, it becomes up to half from positive side and minus half to negative side. And this is called attenuation. So amplification and attenuation. If absolute value of a was greater than 1, then it is amplification. If absolute value of a was less than 1, then it is attenuation. Now what is going to happen if a was negative? So if a was negative, then we call it a reflected signal, and it is just flipping. So upside down. So this portion was down, it flipped to the upside, and these two was up, it flipped to the down side, and then we multiply by 2 to do the scaling. Okay, now let's move from amplitude to the time, which is the second way, and let me change the color to the blue color to link it to this time shifting. Whatever happened before was just concerned to the vertical axis, and now we will be concerned to the horizontal axis. Now, since we're talking about the first type, which is shifting, here we will be talking about a way of addition operation. So now this is the original signal A, and this is the transferred signal to A prime. And let's note that we did not add to the signal the constant. We did not add the constant to the signal itself. Rather than we add the constant to the argument, to the t itself. So we have added t naught for all values of xt. So we have added t naught to the t for all values of x of t. So there are few cases. If t naught were negative, then it will be going to the right. So this is negative, then we're going to the right, and this is what we call it delaying. And if a were positive, greater than 0, then we will move to the left, and this is what is called advancing. So an example of this shifting is radar or sonar. So received and transmitted signals were compared, and the difference between them, this will be the way how we detect or sense the variable that we're looking for. Now here's the examples. So this is the original signal. If t were positive, if t naught were positive, as you can see here, t plus 1, so we are shifting to the left. So we're shifting to the left, and this is called advancing. Second case, if t were negative, so let's see here, it is -1. So we are shifting this to the right. This is to the right, and this is called delaying. So we have to redraw the signal such a way it is delayed by 1 step or 2 steps or whatever t naught. Now, before concluding this, just I want to compare between the time shifting and phase change. If we're talking about sinusoidal signals, then this is the phase that we're talking about. So if there is a change in the time, like we have replaced t with replacing it with t minus t naught, for instance, so if we open the brackets, there will be an effect to the phase of the signal. So the time shifting, there will be an impact on phase change. So for continuous time signals, for CT signals, time shifting always corresponding to phase change. So this is always true. In contrast, also, phase change will always cause a time shifting. So if we did a time shifting, the phase will, of course it will change. There's no way. And if we did a phase change, of course we can change it to a time shifting. However, for discrete time shifting always will get into a phase change. But if we did a phase change, this is not necessary, this is questionable, that we might not get to time shifting since it is an integer numbers. Now, moving to the time scaling, which is the third type of transformation related to the time. And again, this is talking about horizontal axis. And once we're talking about scaling, it is multiplication. So it is either compression or expansion. So multiplying a factor alpha by t for all values of x of t, and just assume that it is positive for the time being. Now we have multiply the argument t with alpha, so it becomes alpha t. Few cases are there. If absolute value of alpha was greater than 1, like 2, 3, etc., then we are compressing the signal. And if that value was less than 1, like half or quarter and etc., then we are expanding the signal. So this is not intuitive, but I have to explain it to you with an example. So as an example, if you are talking about the tape recording and you are played twice the speed, so 2t, so the speed is doubled or tripled, so what you're doing is compressing time. So in a shorter time, because it's faster, it will be compressed. And again, if you're talking about half the speed, then you are expanding the time. So this is with respect to the time, and this is what you're doing is with respect with speed. Let's see it in plots. So this is the original signal, and first, what happens if we are compressing the signal? And when we're compressing, we are multiplying by 2. So we are doubling the speed. So rather than finishing the entire signal between -1 to 1, which is 2, now we're finishing it so quick. We're doubling the speed. So we're finishing it within like just 1. So from half positive to negative half. So this is when alpha is greater than 1. On the other side, we expanding, so we are multiplying by half. So this is half the speed. It is too slow, so it takes much more time to finish it. So this is what we're talking about, and it takes it takes 4 rather than 2. Okay. Now, what happens if we're talking about multiple transformation? Now, for multiple transformation, let's consider all cases. So this is this is scaling for amplitude, and this is shifting for amplitude, and then these two are scaling for time and shifting for time. So let's consider all these happening at the same time. So you have been given the x, and then somebody asks you to find this is alpha, or this is a signal, and this is after transformation. So we have to move it from here to here. So there are different ways how you solve it, but I would recommend you to go with the following steps. So go with the amplitude transformation and start with multiplication. So here's the amplitude, the capital A and B, so A and capital B, and you have to start with multiplication, so start with A. So do A first, then move and do B second. Now, what about time transformation? Move from amplitude to time transformation and start with the summation. So now we have alpha and B, so start with summation, meaning beta first, then go with alpha. So do beta first, then do alpha next. So this order is switchable, but be careful for common factors, because when you switch, you have to take the common factor in consideration. Mathematical expression is translated into linguistically sentences for single transformation easily, but not for multiple transformation. Using MATLAB, you can set T0 equal to the argument between parentheses, and then go with time transformation in this way, and then you can do with amplitude transformation with second equation shown here. Now here are some examples. I will leave it for you to try it off this lecture. This is the first one, and this is second one. Thank you for listening, and see you in the next lecture.